Next we have number 2 from the review. And we have f of x equaling the absolute value and g of x equaling x plus 2 squared minus 4. First, they want me to take negative 2 and plug it into the absolute value function. The absolute value of negative 2 is positive 2. Next, they want me to take negative 2 and plug it into g of x. So I need to take negative 2 plus 2 is 0. 0 squared is 0. 0 minus 4 is negative 4. In C, it's a double problem. You need to take negative 2 and plug it into G, and get that answer and plug it into F. So we're going to take negative 2 and plug it into G, and we already know we get negative 4. That output from G becomes the input in F. So we put negative 4 into the absolute value function, and we get positive 4 as our final answer. In D, take negative 2, plug it into F, we get positive 2. Take that answer and plug it into G and see what you get. So it's another double. Taking negative 2 into F to get positive 2. Take that answer and plug it into G. It's going to be 2 plus 2 squared minus 4. 2 plus 2 is 4. 4 squared is 16. 16 minus 4 is 12. So those are your 4 answers for A, B, C, and D. Next, we have f of g of x. F of x is the outer shell, the absolute value function. Notice I don't write the x. We are replacing that x. We're not writing anything next to that x. We are replacing that x with the entire g of x equation. That goes inside the bars. X plus 2 squared minus 4. That's the composite function. That's one function embedded inside the other. The f of x is the outer shell of the M&M, and the g of x is the chocolate on the inside. All types of analogies I've tried to present to you in order to try to make this make some sense for you. Next, to graph this without a calculator, let's just graph the inner function. X plus 2 squared minus 4. That's going to be a parabola. That parabola has no reflection, no negative in front. It has no dilation. There's no multiplier in front. It's simply left 2 and down 4. So let's graph that basic parabola. Let's move left 2 and down 4. This will be a nice review of graphing a translation. From there, that's your vertex. A parabola's parent function goes 1, 1, back to the vertex. 2, 4. Because 2 squared is 4. Go back to the vertex. 3, 9. So you move 3, 9 from the vertex. And that's going to be the right side of that parabola. The left side of the parabola would just be reflected over its line of symmetry. So if this point was 3 blocks from the line of symmetry, go 3 more to the left and put a dot. Symmetry. Graphing a parabola. Now I know this isn't my final answer because we're supposed to graph the absolute value of this. In order to do that, anything above the x-axis is fair game. It's good. It's graphed properly. Anything below the x-axis is not allowed to be there. What the absolute value bars do, the effect that they have, they make anything that's down the axis flip up into the positive region. So this point that was down 4 should be reflected up 4. This point that was down 3 should be up 3. And this point that's down 3 should be up 3. And it basically causes this to happen. The orange graph is the final answer. You can check that on your graphing calculator.